Okay, I'm Sam Densley, and we're doing part one, question one, and it says, what is the LUCA, and how does the possibility of an RNA world help explain how life originated on Earth? So the LUCA, Luca, is the last universal common ancestor. And so it's just kind of like a starting point for all organisms and species that we know of. And then the possibility of an RNA world helps to explain how life originated on Earth, because RNA has the ability to have both a genotype and a phenotype. So the genotype would be its sequence, and then the phenotype is just how it reacts in different environments. And so it's speculated that RNA molecules could have been the transitional form between non-living and living organisms on Earth. And then as they adapted, then they were able to evolve and change and kind of transfer into DNA and then have multicellular organisms. And yeah, that's what I understood.
Oh, that sounds perfect. I don't have anything to add. So question one of part two says, name and describe the 4 different types of fossils. And so the first type, the book talked about amber and freezing. It's like insects can be trapped in the sap or the amber of plants, which can then harden and they can be preserved, just like kind of like exactly like in Jurassic Park. And also, like, woolly mammoths have been found frozen and preserved really well and they've been dated to 40,000 years. Another type of fossilization is permineralization and replacement. And in this, minerals replace the original organic material. So the structure of whatever the fossil is preserved, but the composition is changed.
Yeah, and then there's 2 others, natural molds and casts. And so that's where the matter is buried, decays, and then kind of like the same way you would make a cast of a footprint for like a crime scene with plaster is really the same way that happens. One part when you pull it apart is the mold, and one part is the cast. And so that can give us a good idea of what an organism looked like. And then the other one is trace fossils. So those would be things like footprints is a really common one, and they can be preserved for like really, really long time. In the book, it gave an example of a 395-million-year-old footprints that were found in limestone. So, yeah. And then for our open-ended question, kind of had to do with the freezing and amber type of fossils. With the book said that they were able to recover incomplete sequences of DNA from a woolly mammoth that had been frozen. So our question is, what can we use from a genetic standpoint? Like, what can we do with the DNA that we recover? Like, do you think there's a possibility we could do something like Jurassic Park, or is there another use for the DNA that we recovered from these ancient fossils? What do you think?